custom-made jewelry by Sylvia Findings, Richmond, BC, Canada. Begin your creative journey right here. 3D scanning service for gemstones.
Hi, my name is Mark Leroux for Sylvia Findings, and I want to show you our OGI Scanox CAD 3D scanner. Now you may be asking what this is useful for. We use this for scanning stones. Why would we want to scan stones? Well, the problem that we find, not so much at shows, which we visit all over the country, and because people get to bring their stones, and we can try them in several settings to find a setting that works. So it's not really an issue if you're there in person, but if you're ordering online and you measure your stone with a caliper and it's 7 millimeters wide, say it's an oval, 7 millimeters wide by 9 millimeters tall, and you go to the website and you order a beautiful 7 by 9 millimeter setting, and then you get the setting and you try to put your stone in it, and all of a sudden the stone doesn't fit. And you can't understand why, because the setting is 7 by 9 and your stone is 7 by 9. The perimeter dimensions are really only one small aspect of the stone size. The other problem is the depth of the stone. Now, traditional stones like diamonds or high-end stones like that are cut normally with pretty close to 41-degree angle from the girdle to the pavilion. That's the pointy piece down at the bottom. But colored stones are not like that. There isn't really a convention. And lapidaries will cut pavilions with really super deep or really super wide curved pavilions to accentuate or deepen the color of a stone, or to increase the carat weight of the stone so they can charge more for it. And that's not always taken into consideration with regards to the seat in the setting that you're working with. So you can have a 7 by 9 stone with a really crazy deep pavilion that if you try to put it in a 7 by 9 millimeter setting, it doesn't fit, and then you're forced to either carve out the seats a little bit deeper or use something like maybe a little bit bigger setting, like an 8 by 10 millimeter setting, and then you have issues where the prongs are not in the right place, and it just gets more difficult. For custom work, and we do a lot of custom jewelry, if we can have a virtual copy, a 3D copy of your stone, the designers will be able to build the setting around the stone. So no matter how crazy the pavilion is, that'll be taken into consideration when they're actually building the actual setting. So let me do a little demo and show you how this scanner works. All right. Okay, so here's the Scanox CAD interface. Here's the scanner part. There's a little turntable down here that you can see my finger against the camera. There's a big lens that takes super accurate measurements. It's super high contrast. You put the stone on the table, and the way the scanner works is it measures the angles and the differences between an angle and another angle, because the turntable will spin the stone around slowly. And the differences between the two angles as it goes will determine the ultimate 3D shape of the stone. Now, this works for stones that have a table on there, or it can also work for a cabochon. The table goes against the turntable. There's a little vacuum that you need to turn on. And if you can hear that little buzzing, that's the little vacuum that's pulling the stone down against the turntable, holding it in place. So as it spins, it stays super accurately in place. Just going to close that. And I'm going to just tell the machine that this is an oval stone. It just helps figure out the angles. And then it's going to start scanning. Now, I don't know if you can tell here, you can see it changing shape a little. And that's just the stone slowly turning on the turntable, and the scanner is calculating the difference between the angles as it goes. And then once the scan is done, once it's all the way at the end, it'll render a 3D copy of that, and initially on the screen there'll be a bunch of information that's super interesting, not especially useful for us because we're just interested in the size of the pavilion and the shape of the stone. But if you were a lapidary and you had the copy of that, you could discover what angle every facet on the stone is. So here's the result of that. It's an oval, length 13.62 millimeters long by 18.9 millimeters wide. The depth is 9.43 millimeters, 69% of the width is this. And here, let's just move this around. So here's the front of that stone. There's the side. And you can see the pavilion is pretty wide. Now the cool thing about this is the table, you see that number 0? If I want to know what angle this facet is, I just click on that. It says 20.8, 47.5, all the way around. Now if you're a lapidary, you can put these numbers into your lap machine and recut many copies of the same stone. This one is actually a pretty good cut stone. You'd be amazed at how some really crazy expensive stones, how irregular the girdle is on the stones, and just how irregular the facets are. These are pretty regular. So from here we can take this and just save this as an STL file. Save that, and then we can take that STL file, import it into the CAD software that we're using to build, and that's it.